information session. And my name is Xie and I'm from ARMA student chapter at University of Houston, and I will be the host today. This information session is collaborated with University of Houston, Texas Tech University, University of Toronto, and University of North Dakota. We are very honored to have Dr. Branko Damjanac to give us this valuable talk. Dr. Branko Damjanac got his PhD from University of Minnesota. He has been working in Itasca for over 20 years. He is also an active member of ARMA. So thank you for being supportive to our student chapter's activities. We will have a short introduction of student chapters first, then give time to Dr. Branko Damjanac. And we will have Q&A session at the end. So please mute yourself if you are not speaking. Before start, we would like to take a photo of this activity. So if you don't mind, please turn on your camera. And we are going to count for 5 seconds.
Thank you.
Thank you. So 5, 4, 3, 2, 1. Okay, thank you guys. And I will share the screen. So first, I would like to invite the president of University of Houston, Bo, to introduce about the chapter. Bo, you can start.
Okay, thank you, Jia. So our chapter established in August 2020. So right now we have 2 advisor, a faculty member, and 6 board members. So we are so honored to have advisor member, Professor Soliman here. Yes, so Professor, would you like to give us some comments?
Not really, but thank you so much for, my name is Mohammed Solomon. I'm the chairman of the Petroleum Engineering Department at University of Houston. And I'm also the advisor to ARMA, actually to our student chapter of ARMA. Actually, this is my second student chapter for ARMA that I start. The first one was several years ago in Texas Tech. We have had a lot of activities. We have very active student chapter, and I hope they continue to be active. I'm sure they will. Thank you so much.
Okay, thank you, Professor. We also have our faculty member, Professor Wipu here. So, Professor, would you like to give us some comment before the information session?
Okay. Thank you. You can hear me?
Yeah, we can hear you, Professor.
Okay. Yeah. This is a good initiation to get students involved in a lot of activities to build the program and also build their future. So that's what I personally encourage everyone to attend this type of presentations so that it is a learning process. So I keep on helping them as much as I can to motivate them to be attending sessions and participate in these conferences. Thank you.
Yes, thank you, Professor. So if you want to follow us, you can join us on our group me or our LinkedIn, or just visit our official website. So we would like to thank our sponsor, Branko. Yeah. So next, I would like to the next chapter to introduce himself.
Thank you, Bo. Thanks, Branko, for accepting this invitation today. I'm the president of ARMA University of North Dakota Student Chapter. Our student chapter was established in July last year. Herher's Polar's hot turtle, and Herher's is contribute a lot to our chapters last year, and this year we will continue to help development our chapters. And Nadia is our vice president. Muhammad is secretary. Choma is on Chuku is the treasurer, and our advisor is Dr. Thomas Chu, who have about 20 years experience on geomechanics, hydraulic fracturing, and well completion. And our student chapter is composed by students coming from a lot of departments, not only petroleum engineering, but also geology department, civil engineering. And we have about 40 members right now. So if you would like to connect, here's a LinkedIn code for connection to our student chapter and web page. Thank you for attending this session today. And next is ARMA GTU student chapter.
Hello, everyone. I hope you guys are having a good time. ARMA TTU, as Dr. Solomon said, he started it. And right now, the faculty advisor is Dr. Hussein Imadi. He was a student of Dr. Solomon, and I am a student of Dr. Imadi. We have a pretty large group at ARMA. Over here consists of 145 members currently. We have info sessions. We have had a couple of field trips as well. Right now, one thing we are considering the most is doing some social work. So I don't know, Texas Tech is here at like Lubbock. We have Lubbock Meals on Wheels, which distributes food to people who are deprived of it. So we do some social work as well. As I said, Dr. Imadi was our faculty advisor. I am Athar, the president. Can you please put in a slide back? Yeah, Andrew, who is also here in the meeting, is our secretary. Ellie is the treasurer. Carlo was the ex-president. He's now the membership chair. Khizr, he's the SORC representative. And Nawed is the chief editor. Sorry, I didn't have all the pictures of everyone. So yeah, it's not here. But yeah, you guys will feel free to follow us on LinkedIn. That's the QR code. Thank you.
University of Toronto.
Hello, everyone. It's a pleasure to have everyone here in this presentation, and the collaboration between the ARMA students chapter just shows how we're getting into this and becoming one strong entity. And hopefully we all share the same vision, which is to provide networking opportunities, like Dr. Suleiman said, help the students in their future. We also hope that these presentations will guide students in their work. And through collaboration and in meetings like this, where it's just open discussion, maybe students can get ideas. And then by sharing these ideas, we can become pillars in the industry for the future. So we started last year, and myself, I'm Ali, I'm the president. May is the vice president. Earl, I believe, is present here, is our treasurer. Kareem is our secretary. Bizawet is our events coordinator, who I believe is also present. And Phyllis is our social media, and she's in charge of doing all our graphics. And like everyone, this is our website. And if you want to join our strong members of around 40 now, who range from civil engineering to geophysics. And we run our Twitter channel and YouTube as well. And again, thank you for all the student chapters for putting this together.
Thank you, Ali. I will stop share first. So Dr. Branko Damjanac, you can share your screen and then start. Thank you.
Okay, thank you. Thank you for inviting me to say a few words about my organization, and I'm very pleased to also learn about these different student chapters from rock mechanics programs at universities. I think mainly in North America. So as I mentioned, I have a presentation, so hopefully going through that presentation will help me kind of provide some information about Itasca. And I'll talk about the company, I'll talk about some of the services and products that we provide. So I'll put my presentation in a presentation mode. And share the screen. Okay, so I hope you see my screen, which shows Itasca logo and 40 years.
Yes,
Yes, we can see that.
Okay, so Itasca is a global company. It's employee owned, and we are very proud of that, meaning that only people working at Itasca can own all shares of the company. And we are engineering, consulting, and software development firm. So company was founded in 1981. So that's why actually this year we are celebrating 40 years of existence of company. And the company was actually started by Professor Charles Fairhurst, who was professor at the University of Minnesota. And his idea was that he and a number of other faculty working at university didn't have a chance to work on a large-scale project and a long-term project. So he thought that, you know, this kind of company provided such opportunity, and then also provided the opportunity for development of different technologies that was not actually possible at the university. And its company started in 1981 as a office in Minneapolis, Minnesota. But over time it grew, and right now we have 14 offices in 9 different countries with over 190 staff. So regarding the name, Itasca is actually name of the lake in northern Minnesota, and it's actually headwaters of Mississippi. And Itasca is actually kind of interesting combination of Latin words, because people who are looking for the source of Mississippi, when they finally found it, they called it true source. And in Latin, that would mean the veritas translation in Latin would be veritas caput. So they took the second part of the first word, which is veritas, itas, and first part of the second word, caput, and that's how they actually named that lake, which is the true source of Mississippi. So the company combines the practical engineering and field experience with expert knowledge of advanced numerical modeling to solve challenging problems in different industries, including civil engineering, environmental, material, and mining. And we are basically focusing on geomechanical, hydrogeological, and microseismic project. So the consulting work is just one part of services that Itasca provides, and the second part is development and making available number of software products And we believe that those numerical software tools are among, most widely used and respected in our field. And the codes include some that you probably are familiar with, like 3DEC, FLAC 3D. And then probably few that are probably less known, like Gradle, CATS, MassFlow, MindDW. And I would say that PFC and UDEC also are quite well known. So I think here at Itasca, we have a fortune to take advantage of beneficial interplay between different activities, which include consulting, software development, but then also doing the research activities funded by industry. So engineers and software developers at Itasca have a proven track record of innovation, which leads to new strategies, tools, methods to better understand the complex environment in which our clients work. So here is the map of the world with location of the current offices. And again, the company started in Minneapolis. And that is currently the headquarters of Global Itasca. We have two more offices in North America, one in Sudbury, which is kind of very much focused on mining, and one office in Denver, and that is center of our expertise in hydrogeology. We have two offices in Latin America. The head office in Latin America is in Chile. Again, another office focused on mining, and the office in Peru is more focused on hydrogeology. We have five offices actually 3 offices in Europe, and head office in Europe is in Lyon, France. We have office in China, Hangzhou, and then office in Australia. And the way things work in today's world, all the offices, for example, in Australia, the head office is located in Melbourne. We have people working remotely for that office in different cities, and it's kind of similar situation in Europe. So I mentioned that Itasca includes 190 staff worldwide, and those are predominantly people with high degrees. So 43% have a doctorate, 33% a master's degree, and 27 among technical staff, 27% have bachelor degrees. And in terms of their backgrounds, so Itasca staff includes civil engineers, geophysicists, geotechnical engineers, hydrochemists, hydrologists, mechanical engineers, mining engineers, and programmers. So I already mentioned this. We have this formula that seems to be working quite well for us, where we do these different activities and provide different services, and that there is this kind of really beneficial, positive feedback between these activities, where we are in the same time consulting company, but also software development. So a lot of ideas for software development are coming from our consulting work and needs of consulting engineers. But then developing these state-of-the-art software numerical tools, allows us to get involved in different research projects And of course, being kind of privately owned business operation, we prefer and usually do research which is directly funded by the industry. And again, advantage of that is that this research is always focused on providing a practical solution to the industry. So we use these software tools then to do research, which then results in some new engineering tools, solutions which are used by our consultants. So over 3 years, we have been solving different geomechanical and hydrogeological challenges through engineering design and computer simulation. So, as I said, I mean, we are involved in different types of problems, which you can see in a subsequent in the following slides. But the two main activities in terms of consulting are basically geomechanics and hydrogeology. So in geomechanics, we basically solve the problems related to behavior of geomaterial soils and rocks on wide range of different scales, from grain size, microcrack scale to scales of boreholes, tunnels, to the caverns and largest underground mines and deepest open pits in the world. And in hydrogeology, we have extensive experience in deciphering complex hydrogeological systems, associated with ore bodies, highly fractured rocks, and complex depositional and tectonic environments. So I'll go now through maybe a few slides just to kind of give you an idea about activities that we do for different industries. So, I mean, different project types of problems solved, and then are kind of listed, and then also kind of nice pictures illustrating some of our modeling results. So here for the mining, you see here, example of open pit stability, then tailings dam stability, block caving in the lower left corner, and then design of the ground support for the underground excavations. So in mining, types of projects that we get involved are open pit and surface mining, underground mining, caving. So this is example of the caving problem. Solution mining, materials handling, tailings and the waste rock handling, underground coal gasification. So working with this project, we solve different types of problems. So excavation, stability and ground control, design of ground support, design of infrastructure for the mines, looking at subsidence. We can also see, we also do simulation of the blasting efficiency. So for block caving operations, we do analysis of cavability and fragmentation, analyze recovery and of the resource and dilution, analysis of the backfilling of the excavations, tailings impoundment, then also tailing dam design and stability, including dynamic stability of tailing dams, solution mining for caverns in the salt, heap leach optimization, mine dewatering, further water supply quality and resource impacts, hydrogeological characterization, rock mass characterization. So here is the similar slide for our civil consulting work. So we work on projects related to tunneling, underground space and large caverns in the rockfill and concrete dams, levees, subsurface excavation, cut slope, earth retaining structures, harbor structures, wharves, foundations, railways, roads and bridges. So specific problems that we solve related to those projects include site characterization, soil, soft ground behavior and creep, intact or jointed rock and high stresses, slope stability, tunnel support and design, ground structure interactions, settlement analysis, dynamic analysis of structures and liquefaction, evaluation of liquefaction potential, groundwater flow, design reviews, soil stability, and so on. Then we also provide services to different industry, which can be roughly characterized as an energy sector, which include oil and gas, geothermal, nuclear waste disposal, hydro energy projects. So the project types would be conventional, unconventional oil and gas reservoir, well completion, enhanced recovery, fluid injection, cutting injection, EGS, engineered enhanced geothermal system, hydrothermal, geothermal, nuclear waste reactor plants, nuclear waste isolation projects, wind turbines, hydroelectric dams, hydroelectric powerhouses, and you know, pump storage plants, CO2 sequestration. Again, related to that type of problem that we solve, you know, site characterization and suitability, cap rock excavation and integrity, enhanced oil recovery, flowing fractured rock, hydraulic fracturing and injection, use seismicity and microseismicity, wellbore drilling, optimization, stability, water and oil quality and impacts, compaction and subsidence, reservoir scale modeling, salt cavern formation, stability, fault stability, movement, reactivation and integrity, engineered barrier evaluation related to the nuclear waste disposal, you know, long-term stability of the rooms for nuclear waste disposal, and performance assessment, dynamic response to earthquake, hydromechanical thermal coupling, you know, applied to different types of projects, borehole breakout and sanding. And then for hydrogeology, you know, the projects can be classified into environmental geochemistry, mine design optimization and closure planning, civil construction, nuclear waste containment, and type of problems which are solved include field investigations, water quality supply and management, dewatering, depressurization, mine water disposal, environmental assessment of environmental impact, environmental permitting, groundwater flow, multi-phase flow, chemical transport, and so on. And then also related to materials, you know, we look at ore conveyance, pharmaceutical manufacturing, material handling, grain handling. So for this type of problem, we typically use the particle flow code. And you can see on the right side some of the picture illustrating use of PFC for these types of projects. Mixing of material, granular material mixtures, granular material flow, slurries, drilling and cutting, and again, type of problem, batch or continuous mixing, upscaling of production, packaging design, optimal design of continuous mixers, powder compaction, auger design, wear and noise estimation in conveying facilities, and so on. So we believe that Itasca has a proven track record of innovation that leads to new strategies and tools to better understand these complex geo environments. And I think we are in a good position to do this kind of research because large number of our engineers, you know, possess advanced degrees, but then also have a practical experience. And we were fortunate to work on a number of these research projects, and 3 of such done in the last 10, 15 years that have been actually funded by mining consortia of mining companies, or large open pit project where we looked at different issues and a problem related to design of large open pits. Then mass mining technology. So this project was focused on development and understanding development of new technologies and methods and understanding of the process associated with the caving mining method, which is used more and more around the world. And then hybrid stress bus model, where we actually develop numerical tool to analyze the blasting process, but not only blasting itself and fragmentation of the rock, but then also some of the associated long-term and for mining very important processes, which is throw of the blasted material and so on. And we've been involved in a number of projects funded by United States Department of Energy, where we analyzed the viability of the EGS geothermal projects, sedimentary heat. Right now we are involved in a FORGE, which is field observatory for research in geothermal energy, again project funded by DOE. And on these projects we work with US national laboratories, including Sandia, Idaho National Laboratory, Oak Ridge. But we also get involved, or work on these projects with different US universities. So in order to stay at the forefront, to have the capable and educated staff in our company, we try to maintain very close relationship with educational organizations and research organizations and universities worldwide, and we provide so-called Itasca educational program. And probably some of you guys are actually part of or are taking advantage of this program, where we basically support students that work on some relevant and interesting research topics, and the support is in form of providing free software, but then also some training and mentorship. And we also have a Itasca teaching program, where we actually provide free copies of our software that are used by faculty at universities, in their basically teaching and their coursework. Okay, and then, so those are two kind of activities, which is consulting and research, and then third one is software development. So we develop and make commercially available, provide technical support for a number of different software tools with application to different problems related to geomechanical materials. So some of those tools are kind of shown here with their logos or icons. And I'll go just real fast through them. I just don't want to take too much time, because I would like to leave you some time for the questions. So FLAC and FLAC3D, those are two continuum codes. FLAC is two-dimensional, FLAC3D is three-dimensional. So they're continuum codes, but they can still include a number of discontinuities. So it's based on finite volume or finite difference approach. The codes can solve relatively efficiently, highly non-linear, both in terms of material behavior, but geometrically problems. And that's the main functionality, but then they also do not all they are not solving only the deformation and plastic flow of materials. They also can solve different transport processes, including groundwater flow, heat conduction, heat advection, and then these processes, can be coupled with each other, and also with deformation. The codes are quasi-static, but they then also can solve dynamic problem. So next two codes are UDEC and 3DEC. Again, UDEC is two-dimensional, 3DEC is three-dimensional, and they're used for solution or simulation of mechanical interaction of large number of polygonal or polyhedral blocks. They're well suited for simulation of behavior of fractured rock mass, but then also can be used for analysis of, let's say, for example, masonry structures. The interfaces between blocks represent the fractures, and those fractures can slide open, and interaction of the blocks is fully general, meaning that code resolves, contacts as the model evolves. And again, similar, I didn't mention in talking about FLAC and FLAC 3D, the code can also simulate different types of structural elements that represent ground support, like bolts, beams, and so on. And then as FLAC and FLAC 3D simulate porous media flow, these codes can simulate actually fracture flow. And again, that flow can be simulated as fully coupled with mechanical deformation. Next are PFC 2D and 3D, and originally they're developed for simulation of flow of bulk materials, granular materials like grains or sand or gravel, whatever. And there's some illustrations on the right side of such use. Recently, the code was generalized. So originally the particles were cylindrical or spherical. Now you can actually represent arbitrarily shaped particles. But then in addition to use of PFC for simulation of bulk flow of bulk material, actually we found that if you kind of create of assembly of these packed particles and then you glue the contact between them, that synthetic material actually quite well represents behavior, deformation and damage, cracking of the brittle rocks. And there is a lot of research actually done using this approach, sometimes called bonded particle method or bonded block method, depending on what kind of shape of the particles was used. So Griddle is just a kind of tool which is used for meshing, and meshing is a very important step in building these models, particularly, let's say, 3D continuum models. So Griddle is a plugin that can be actually for a Rhino, which is 3D third-party 3D solid modeler for the definition of the different 3D geometries. So then with Griddle, you can actually very easily create meshes which are easy to simulate in numerical codes with relatively uniform size distribution, avoiding some let's say awkward geometries with bad aspect ratios. And then with the Griddle you can develop, generate either hex or tat meshes depending on the code. And MindDW is basically a code, general groundwater flow modeling tool developed by our Denver office, and it has different capabilities. To be honest, I don't know much, and I haven't been used, but it is a very efficient model for simulation groundwater flow related to mine operation and so on, either open pit or block caving or underground mine. CAD software is developed by our office in Chile, and it's a tool for a really quick analysis of kinetic stability of wedges created by pre-existing fractures and excavation surfaces. Excite is again the special purpose code, unlike let's say FLAC 3D, UDEC, 3DEC, which are general purpose code. Excite is special purpose code developed just for simulation of hydraulic fracturing. It is based on a relatively novel approach, which is lattice, where you actually use a kind of lattice, which is array of nodes in some kind of quasi-random geometrical arrangement connected by springs. And so it's actually very similar to PFC. It's kind of simplified version of PFC, where particles are replaced by nodes and contacts are replaced by springs. So then, by doing so, we actually improve computational efficiency, and we use then lattice to simulate the hydraulic fracturing. And using lattice, we have a tool that has capability to simulate hydraulic fracturing, where hydraulic fracture trajectory is part of the model solution. It's not predefined. And again, being a special purpose code, it has capability to simulate hydraulic fracturing from multi-stage simulation, from multiple boreholes. It can also simulate proppant transport and placement, and has capability to generate induced microseismicity. And it can also simulate hydraulic fracturing in a continuous medium, but then also it has capability to represent explicitly thousands of pre-existing fractures, so the actual DFMs. Here is an example of actually a special constitutive model that we have developed with idea of simulating the block caving operation in a continuum code. So it's called IMAS, and it has capability to represent damage around excavation. So it accounts for progressive failure and disintegration of the rock mass from intact jointed rock mass to bulk disintegrated materials. So it has all these very complex strain softening models with non-linear failure envelope. And then, since strain softening generally in a framework of continuum mechanics results in a mesh size or mesh dependent results, this model automatically does rescaling as a function of mesh size to avoid that problem. And then another tool which is used for simulation of block caving is actually a tool that's going to be released in next year. So it kind of simulates the flow of material in a cave as a result of basically drawing material at the draw point. So it is not tool like PFC, where it actually explicitly represents every particle, but it is kind of combination between continuum and particle flow code, which allows actually much faster simulation of these problems and processes. And then there are two more codes which have actually almost same formulation as Excite, which is lattice-based code. And I mentioned that actually we worked on the research project funded by mining consortia to simulate the blasting of the rock, shockwave propagation, rock fragmentation, and throw of material. So one code is blow up or HSBM. And then the other code, which is actually developed for LOP project, and the code is used for simulation of stability of walls of these large open pit mines excavated in fractured but brittle rocks. So here's just some illustration of the blow up, where you can actually specify location of these different blast holes, and then the code actually simulates wave propagation. It simulates induced damage, cracking, fragmentation, and then it can also simulate the throw of the material as a result of blasting. And here is the illustration of some of the results of the slope model. So here we actually compare the results of slope model with results of the laboratory test. And this is very interesting problem because it actually shows this failure of the slope, which is combination of actually two mechanisms, and one is sliding on a base fracture, and again this base fracture is actually not predefined. It is basically induced fracture as a result of cracking of the rock. So that's one mechanism, and then the second mechanism is actually toppling, because actually this rock is highly anisotropic with kind of subvertical planes of weaknesses, and you can actually see this toppling effect in the contours of the displacement, because you can see that these contours are actually offset on some of these subvertical pre-existing weaknesses, planes of weakness. So wherever they are kind of mismatched, this is basically a location where these planes are slipping relative to each other. Okay, so this is what I plan to show to you guys. I've seen in the email by Shuling and Bo that you guys are interested in internship opportunities at Itasca, and also in what are the recruitment plans, so or hiring plans at Itasca. So we like to have interns in our company, and typically we put that in our plans for a year. And I know for the next year that we have planned for at least one intern, but depending on how many people, and then also on the quality of applications, we are certainly open to considering or having more interns. So what I will do is I'll send you an email of a person who is basically handling applications for internship. So basically what you should do is, if you are interested in internship at Itasca, send your CV and indicate that you are interested in internship position at Itasca. So I'll send that email to Shuling and Bo, and then you guys can basically then distribute that to everybody else interested. In terms of hiring, I think we are actively looking for young, good, capable people. And I think you should check Itasca website. And again, there is information if you are interested to apply for a position at Itasca. So you can see exactly what kind of profile you are looking for, and what are the conditions and what you need to do in order to apply. Okay, this is what I prepared or planned to say. So I think we don't have too much time, 8 minutes, but maybe I can answer a couple of questions. If not, I'm still open. Send me questions in emails and I'll try to answer them. So.
Thank you, Dr. Damjanac. So anyone who has questions, please unmute yourself and go ahead and ask.
We have a question in the chat. I will read this one. Thank you for the presentation. This is question from Lily. He is asking, or she, sorry, are there any recommended materials that can be found to help us get familiar with Flag 3D?
Okay, I'm sorry, can you please repeat the question? I'm sorry.
Yeah, sure. Are there any recommended materials that can be found to help us to get familiar with Flag 3D?
I mean, I think maybe if you go to Itasca website, you might be even, I'm not sure 100% sure, but you might be even able to download some kind of electronic version of manual. I mean, there's a lot of different information, papers in journals, in conference proceedings on Flag 3D and Flag 3D results. Yeah, so yeah, please go. I mean, you can even download the, I think, demo version of Flag 3D, which has all functionality, but the size of the model that can be simulated is limited. And if you do that, actually what you will get is also the online manual. Maybe it's not easiest thing to, because with online manual you cannot just go and start reading, because the information is related to the particular question or problem that you're currently dealing with. So but I mean, that's maybe one thing to start with. So
yes, thank you, Branko. Based on your recommendation, I just checked the website of Itasca Flag 3D, and here it shows software documentation for 3 versions of Flag 3D here. So Lily, maybe you can find from
yeah, please check that, and if you still have issues or problems, let me know, and I'll try to direct you to somebody who can help with that.
We have one more question from the chat. So Shelin, can you read it?
Yeah. So Nadia is asking, is there a free available version of Flag 2D for students?
I mean, again, if you apply to IEP, I mean, as a part of IEP, you would get free version of Flag 2D, but I don't think you can get Flag 2D just as a student, kind of independently. Yeah. So.
Yeah. Thank you, Branko.
Sure.
Is there any questions?
Yeah, there are one more if you go up.
Oh, okay, I see. Serhi is asking, how does the lattice method in Excite accelerates the computational speed, and how fast it is comparatively to the boundary element method for fractal initiation or propagation?
Oh, it's way slower than bound element method. I mean, but I think it does include more complex, physics, and it's faster because the lattice is faster compared to, let's say, PFC, for example, because it doesn't update geometry of or location of the nodes as a result of deformation. So basically, it assumes small strain, small deformation. So that's for example one reason why lattice is faster than PFC.
Thank you. Do we have more questions? Xujia, do you receive more?
Yeah, I think Sadra is going to ask.
Yeah, and can you hear me now?
Yes.
Hello, everybody. Thank you for organizing this event. It was really helpful and informative for me. Actually, I'm doing PhD in Canada. I'm using Fleck 2D for my PhD project, and I'm doing a coupled analysis. Sometimes I face with some problems like in the manual. I was wondering what other resources are there in the Itasca company to get help, because I'm using the,
Yeah, we have people who provide technical support. So, and I think the person for Fleck technical support is Jim. I mean, but you can contact anybody at Itasca and they'll direct you to the person, with specific question or, No. I mean, we do provide technical support for all our code.
Yeah, what specifically I was looking for is that do I need to hire a tutor, an engineer from Itasca to help me with my problem, or?
Well, depends. If it's technical support, something related to code, there are problems, then it's of course free of charge. If it's you asking us to set up your model, then.
Oh, okay. Thank you for your help.
You're welcome.
I think we can maybe have one more question. So
can I have a question, Xujia?
Yes, go ahead.
So hi Branko. So I think the Itasca provides so many software for us, especially for engineer students. It's very useful. So my first question is about it. So right now, what area the Itasca can do to improve the software performance? In other words, what's the disadvantage of the software, like Excite, Fleck, or UDEX, some kind of? So what's the maybe the big challenge or so?
It's speed, calculational speed. It's making codes run faster. I think if there is one area where people complain about our software tools is execution time. So that's basically the main area on which we are working right now, and it includes different strategies, starting from changing algorithms to maybe taking advantage of these supercomputer center with basically developing API versions of the code where they run on multiple machines in parallel.
Okay. So you mean the computational very expensive right now?
Yeah.
Algorithm used. But the problem is the software can cover so many details, but so many mechanisms involved in the but the problem is time consumed. So it's some kind of we should make some sacrifice if we want to cover this more detail.
That's the other approach, which is with people in engineering are using more and more, which is called using some kind of surrogate models, where you kind of create a model which is doesn't include all details, but like some kind of like machine learning or whatever, where your model, you develop a simple model, but then you train your model with the results of this detailed model, which run long. So then you can use your surrogate model, which runs real fast, to basically generate the large number of results to address uncertainty and variability and so on.
So can I have a following question? You just mentioned about this machine learning. Yeah, it's very hot topic. Yeah. So
yeah, well, I don't know much about that. Okay, but
okay. So my question is, so right now, the machine learning is very popular. So for our for our engineering students in civil, in mechanical, or in machine engineering, so how can we prepare for this kind of digitalization transition? So since we have so many years background in the engineering, so do you have any suggestion for us to prepare for the new age?
Oh.
So
yeah, I mean, of course. I mean, I think the most important thing is, your learning process never stops. So just be curious and exactly, I mean, as you said, go and look for whatever is currently, the new topic in the engineering and science, and try to understand and keep up with all new development. That's I think that's probably the most important thing.
Yes, thank you. We should keep learning.
You're welcome.
And it's new, how to say, make a compilation. So take the machine learning model and the AI as a tool to apply these tools in our background in the engineering fields. Yeah, maybe.
Yeah.
Thank you, Professor.
Thank you.
Thank you. Can I have one more question?
Yeah.
But real quick, because I don't think I have much time. So.
We have attendees, Mohammed Soliman from University of Houston. He found a lot of information in your presentation. He's asked if we can have the PDF version of the presentation because he left in the middle of the meeting.
I'll send you the PDF version. Yeah, I'll send you PDF version. I'll send you the email of the person that you should contact for if you're interested in internship. So
thank you.
Thank you.
Thank you,
This was great.
Dr. Damjanac. Thank you for being here. And once we have all the materials, we will post on our social media. So if you want to check, please follow us. Okay, thank you.
Thank you.
Thank you very much.
Guys, have a nice weekend. Yeah.
Thank you.
Thank you,
Have a nice
Dr. Branko.
weekend. Have a great weekend. Yeah.